Hello, I'm Mateo Meo, and today I'm excited to be speaking with Deepu Pillai, Senior Manager of Strategy and Market Intelligence at SES. In this interview, we'll explore the strategic role of SES MEO constellation and how it supports the telco, enterprise, and government sectors. Deepu, before we begin, could you briefly introduce yourself?
Good morning. My name is Deepu Pillai. I am working in the Strategy and Market Intelligence Department of SES, and I am supporting the Enterprise and Cloud business unit within SES.
Thank you, Deepu. Great to have you here. Let's start with the first question. SES operates satellites in both GEO and MEO orbits. What strategic advantages does MEO offer over GEO and LEO? And why did SES choose to invest so heavily in MEO with O3b mPOWER?
So SES decision to invest in medium Earth orbit, that is MEO, was both visionary and pragmatic. This is because the MEO orbit occupies a unique position in the orbital landscape, delivering a much lower latency than GEO, which is typically around 150 milliseconds round-trip latency. But it is coming with a much more consistent coverage and capacity density than the LEO constellations, which often require hundreds of satellites and complex handovers to have the global coverage. With O3b and now O3b mPOWER, we recognized early that the global enterprises, government, and mobility sectors needed very high performance, carrier-grade connectivity that matched the terrestrial experience, particularly in remote or underserved geographies. So the MEO orbit lets deliver fiber-like performance over satellite without the limitations of GEO's latency or the LEO's complexity or the huge investment required in the LEO constellation. So strategically, MEO gives us the ability to differentiate our services with providing consistent SLAs, higher throughput per beam, and flexible scalability. That's why SES views MEO as not as a compromise between GEO and LEO, but as a purpose-built layer optimized for high bandwidth, latency-sensitive, and mission-critical applications.
So, let's dive into the interview. Thanks for that overview, it really sets the stage. Now, let's move on to the technology itself. O3b mPOWER is often described as a game-changer in satellite connectivity. What are the key technological innovations that set it apart from previous O3b systems or competing LEO constellations?
So O3b mPOWER is the most advanced MEO systems that ever deployed. So unlike the classic O3b systems, which is the first generation O3b systems that we launched, the O3b mPOWER is a fully software-defined systems allowing us to steer, shape, and scale thousands of beams in near real time. This means that the customers can get the bandwidth that dynamically allocated to where they need it most. That is, for example, in a cruise ship crossing across Atlantic or in a cloud region needing the instant scale-up of the connectivity. So each O3b mPOWER satellite can deliver multiple gigabit of throughput per second to a single terminal with the total throughput in terabits per second across the constellation. This is a massive leap considering the first generation of O3b systems. So we have also architectured O3b mPOWER to seamlessly integrate with the terrestrial network, and that is a big differentiation compared to the classic systems. So the net result is very simple. So with O3b mPOWER, we provide a guaranteed performance, low jitter, and flexibility that adapts to the customer's operational tempo.
That's impressive clearly. It's more than just incremental progress. Let's talk now about how these innovations apply in real-world scenarios. What are the emerging applications where MEO and multi-orbit connectivity are proving to be the best fit solution?
So the most impactful emerging applications for O3b mPOWER would be the ones which require a higher throughput, low latency, and reliable services continuously across remote, mobile, and mission-critical environments. For example, in the enterprise and cloud business unit, we have energy and mining applications where we are enabling the digital transformations through artificial intelligence-driven edge analytics, autonomous vehicle operations, real-time monitoring, and digital twin environments. These use cases demand a very low latencies, up to 100 millisecond latencies, and a fiber class performance with high reliability and predictability. And this is also in areas where the terrestrial infrastructure is not viable. So here is where the O3B mPOWER is highly relevant. O3B mPOWER is also relevant for applications for the mobile network operators who are deploying the 4G and 5G systems in deep rural areas. Here, the multi-orbit satellite network also plays an important, where the MEO delivers a highly predictable, high throughput, high reliable connectivity, and we can also complement that with GEO or LEO networks, where the cost efficiency is more important than a high performance connectivity. So for the government and defense also, the multi-orbit and the MEO plays a very unique role. With solutions like the Iris Square and the hybrid GEO-MEO architecture, we can enable encrypted sovereign-ready communications that bypass the terrestrial network infrastructure. This is especially ideal for tactical mobility and critical infrastructure. In mobility for aviation and cruise and land mobility, the multi-orbit enables us multiple applications. For example, meeting the operational requirements, streaming, crew communications, and real-time applications. For aero, our open orbit platforms, which leverage on GEO and MEO networks, can deliver multi-orbit, multi-gigabit IFC connectivity to the customers. So, looking ahead, we are preparing for orbital relay and in-space AI mesh networking, where the LEO to MEO to GEO links will support persistence, ISR, Earth observations, and sensor to cloud connectivity applications. Ultimately, for applications where performance can't be compromised, even at the edge of the grid, the right fit solution is MEO or a tailored multi-orbit networks where the MEO plays a pivotal role.
Very interesting. Now I'd like to ask about how SES is working alongside key partners in the industry. With 3GPP-NTN standards and D2D accelerating, how does SES work with telcos and hyperscalers to make it real?
That's a very good question. So here we are ensuring that we are taking an end-to-end approach. So we are making sure a technical alignment, the commercial code development with the telco and hyperscalers, as well as a deep integration into their networks. So on the technical front, SES is one of the first satellite operators to adopt to the 3GPP NTN framework, specifically the Release 17 and the Release 18 standards. So these standards enable us to natively address within the telco cores, which means that the mobile operators can integrate SES service as part of their network, whether it is for mobile backhaul, Internet of Things, or direct-to-device. Commercially, we are also working directly with several of the global top mobile operators like Orange, Claro, Reliance Jio, Airtel, etc., to deliver the Jio MEO services to their 5G and 4G rollouts. These aren't simply off-the-shelf offerings, but these are solutions which are co-engineered to plug into the local network infrastructure, matched with the SLA requirements of the customer, and enable new business models for the customers. On the hyperscaler side, we are working closely with the big hyperscalers like the Amazon Web Service and Microsoft. We are building the cloud edge integrations that allow workloads to shift across orbits dynamically depending on user proximity and latency requirements. We also made a $20 million partnership with Link, which is a standout example in the direct-to-device market landscape. So together with Link, we are creating a 3GPP aligned multi-layer D2D architecture, integrating the LEO handheld links with our GEO and MEO backbone for global scalability. Meanwhile, we are also making sure that we are embedding APIs and network intelligence via software platforms like QVR, making satellite not just compatible but programmable on par with the terrestrial slices or cloud edge nodes.
That's exciting. Partnerships like these are really driving the future of connectivity. Let's turn to innovation now, especially around AI and orchestration. With real-time analytics, network orchestration, and AI pushing the boundaries, how is SES preparing its infrastructure?
SES is redefining itself from being a bandwidth provider to a smart infrastructure partner. The backbone of the transition is network intelligence. Through platforms like ARC and QVIA, we are embedding AI directly into the heart of our networks. This includes beam switching, bandwidth predictions, and application level traffic steering. In practice, that means that we can prioritize video analytics to an offshore rig or reroute resources for an autonomous drone fleets in milliseconds. For instance, also in applications like in mining, the predictive maintenance and autonomous orchestration demands ultra-low latency and deterministic connectivity that only MEO can deliver. We are also working with cloud edge partners to co-locate processing closer to the user. Additionally, we are also investing in enabling our systems with adaptive routing and programmable APIs, and we are building an ecosystem where satellite isn't just fast, it is contextually aware. It can interpret, adapt, and optimize based on the specific needs of the applications. That's why AI and edge-ready satellites look like a performance with a foresight.
Great to hear how future-ready SES is. Now, looking ahead to the evolution of mobile networks, as private 5G and eventually 6G scales, what role do you see satellite playing in this evolving ecosystem?
Private 5G and 6G networks present a huge opportunity for enterprises to take their connectivity to the next level. And we believe that satellite would be fundamental in delivering that services. So satellites, as industries expand to remote geographies like mines, offshore platforms, and disaster zones, they would need a high SLA, a guaranteed throughput connectivity. That's where SES comes. Our MEO system is already delivering a MEF certified carrier grade performance indistinguishable from fiber. We are also aligning with the 3GPP 17 and 18 standards, as I mentioned before, so that we can provide seamless interoperability with the 5G networks. And also include features like slicing and direct-to-device into our networks. In sectors like mining and public safety, we are co-deploying private 5G networks with satellite backhaul as the default transport layer. On enterprise side, we are seeing a strong demand for NTN-enabled hybrid networks with full programmability. We are co-developing solutions that allow telcos to extend private networks with satellite, including spectrum sharing and local breakouts. Looking ahead, we believe that 6G will be rolling out soon, and AI network architecture will demand global, resilient, and intelligent edge infrastructure. And that's exactly where we believe that our future generation constellations and our multi-orbit networks play a key role in delivering the high-performance connectivity.
Makes perfect sense. To close, let's look at some of the challenges involved in making this work at scale. Every orbit has its trade-offs. What are the biggest technical or operational challenges SES faces with MEO, and how are you addressing them to ensure reliability and scalability?
So, as you pointed out, every orbit comes with its own challenges. So, of course, MEO orbit also has its own operational and engineering challenges. So, unlike the geostationary orbit satellites, for which the ground station networks can point to a fixed satellite from the Earth, the MEO satellites appears to be moving across the sky, and so it requires a network of gateways and tracking antennas that can maintain consistent connections as the satellite passes. So this makes our ground systems more complex compared to the geostationary systems, or even the LEO systems where multiple hundreds of satellites are there in the constellations. To solve this, what we have done is that we have built one of the most advanced ground networks with intelligent gateway diversity, automated beam handovers, and extensive fiber interconnects. We are also heavily investing in the virtualization and software-defined networking to ensure that seamless service delivery across orbital changes can happen. And then the other challenges that we face is regulatory frameworks, especially in the spectrum coordination and cross-border access. So here we are making sure that we are working closely with the national and international regulators for ensuring the compliance while we expand the MEO coverage. From a customer integration standpoint, one of the biggest breakthroughs has been simplifying the end user experience. With mPOWER, service delivery is abstracted to a service level interface. So customers don't have to manage the orbital complexity. They get an SLA based service that behaves like a dedicated lease line on MPLS circuit. So ultimately, I would like to stress the fact that MEO may be complex under the hood, but our goal is to make it feel simple, scalable, and enterprise ready for our end customers.
Thanks so much, Deepu, for this insightful interview. It's been a pleasure hearing your perspective on how SES is shaping the future of global connectivity.